For today's demonstration, we will use this test bench that includes an ADV200 3 kilowatt drive, 400 volt, a control box that is simulating an external operator or an external controller giving command to the drive, and all the feedbacks that are needed in order to give the status from the field to the drive itself. And an asynchronous motor, 1.5 kilowatts. In order to perform the commissioning, we need to switch on the drive. To perform the commissioning, we will use the standard keypad already installed on the drive. The keypad has different buttons to navigate throughout the parameterization. Some of them are dedicated to specific functions. For example, forward reverse is needed in order to change the direction of rotation. Local remote can move the commands to local or remote through external sources. Reset is used to reset the faults on the drive. Custom may show you the last 10 parameters which are modified in the drive. Display will switch to a view of the main status information of the drive, and Ask will bring you to the upper level menu of the display. The Enter key is used to set the parameters. The value may be changed through the arrows, and then we have the Start and Stop buttons. In this case, the keypad is installed directly on the drive. The keypad can be used to configure the drive, visualize status information, and copy the parameters of the drive into the keypad memory. There are 5 different memory areas available. This may be also useful to transfer parameters between drives. Before starting the commissioning means a motor must have been already wired. The Enable Digital Input on Terminal 7 must be closed, as well as the safety STO contact if present. In case you would like to operate with a regulator mode that is different from the default, that is voltage on frequency, you should first of all change the parameter in the drive configuration, that is the regulation mode. We can proceed to the Startup Wizard. The Startup Wizard is a guided procedure used for quickly start up the drive and help to set the main parameters. It consists of a series of questions related to the various data of motor and information about the application. If we start it, the first information it will ask is if the user would like to set the motor data. We will answer yes to that. As you see, there is a sequence of data that are requested by the drive. First one is the rated voltage, 400 volt is correct. The rated current, we will need to change it to 3.3. The rated speed, in this case the motor has 100 RPM sleep, so the correct setting is 1400 RPM. The next one is the rated frequency, it is 50 Hz. The pole pairs is 2, it's correct. Rated power is 1.5 kilowatts. And the rated power factor needs to be changed to 0.79. The operation that follows is the self-tuning of the motor. This procedure is used by the drive to measure the real motor parameters. The first choice is the rotating self-tuning. Use the procedure when the motor is not coupled to any loads, or the transmission does not represent more than 5% of the rated load. This procedure obtains the most accurate data. It may take a few minutes to be completed. If the motor is coupled to the transmission and cannot rotate freely, press down and go to the self-tuning with motor at standstill. In this case, we have no load, so we can proceed with the rotating auto-tune. As you see, the drive asks us to close the enable input, that is the digital input 7. And then we can proceed with the execution of the auto-tune. During this procedure, the motor is turning and the drive is calculating the motor data. At the end of the self-tuning procedure, that is the request to open the enable input, and in this way, the take tune parameters is automatically executed in order to save the motor data calculated by the self-tuning procedure in the drive. The next step is the setting of the maximum speed reference value. In this case, we will leave the maximum speed up to 1500 RPM. This is the value that can be reached with each single reference signal, analog or digital. In terms of overspeed threshold, that is the maximum speed over that the drive will show us an alarm, we will leave 1800 RPM. The drive now is asking to set the ramps, the acceleration ramp and deceleration ramp. We will proceed. For the moment, we will leave them to the default value, that is 10 seconds for the acceleration time and 10 seconds for the deceleration time. The next step is the parameter saving. Now it's done. In order to visualize the current status of the drive, let's press the disp button on the keypad. This will allow us to see the current information that the drive is reading from the field. For the first test of the system, we will leave all the parameters to default values. It means that the motor will be set to asynchronous. The regulation mode is voltage on frequency, and analog and digital commands are left to their default values, which is the digital input 0, that corresponds to terminal 7, is the enable command that we already said is mandatory. Digital input 1, that is related to terminal 8, is the start forward input. Digital input 2, that is terminal 9, is the reverse command. And this is the potentiometer that we will use to provide the speed reference to the drive. Before starting, make sure that the analog signal, in this case from the potentiometers, is set to minimum value. First step is closing the enable contact, and the start forward. We start increasing the analog command in order to increase the speed of the motor. In this way, we will see if the motor is rotating in the right direction. So the positive direction, looking at the shaft of the motor, is the clockwise sense of rotation. In case the direction is not what you would expect, you will need to invert a couple of phases of the motor in order to make it turn in the opposite direction. If all the parameters are correct, increasing the analog reference to the full scale will give us a final frequency of 50 Hz and the current that is the magnetizing current of the motor, since we have no load at the moment. In case the motor does not reach the maximum speed, probably a self-tuning of the analog input should be performed. In this case, there is a parameter that has to be set to 1 in order to perform this operation. Same thing in case, coming back to the 0 Hz, the motor still has a reference and the shaft is still turning. In case you would like to move the motor on the opposite direction, you may close the reverse command and the motor will turn in reverse. You can see that the frequency on the display is negative. To stop the drive, you need to remove all the starting commands. Just for information, in case you are running the motor at a specific speed and you will open the enable command, the motor will be stopped with a coasting operation. It will stop by inertia. We have reached the end of this tutorial about the commissioning of ADV200 AC drive. Please consider that all the information about the installation and parameterization of the drive may be found on the manuals you may download from the WEG website. Thank you for watching this video and stay tuned for more videos to come.